So I was given a remit to talk to you about air quality and effects monitoring this morning. My background is more in the air rather than the actual ecosystem effects, so apologies if I get any biological terminology wrong. What I'm going to try and do is summarise some of the key monitoring activities that occur in the atmospheric domain in the UK and how we sit internationally currently, and some examples of emerging information and how that applies to our scientific understanding, how we manage our air and our environment, and the policies which need to be put in place around that. Air quality and climate variables, so air covers both what we would term climate pollutants, so your carbon dioxide, your nitrous oxide, but also your air quality pollutants, things which have a direct impact on human health or ecosystem health. So we're talking about sulfur dioxide, acid rain, which is now thankfully mostly solved, but through to your nitrogen pollutants, your ozone, your particulate matter. So how does air affect you? Well, it can either cause short-term chronic damage. So if you get too high a dose of any chemical, that is deleterious to your health, whether you're a plant or a human. So that is obviously clearly something which in most of the environment and in our cities we want to avoid. More difficult to understand and monitor is the long-term cumulative damage, where you may be gently injuring over time, so that you reduce the capability of a system to thrive, or that you enhance one set of the population against the existing part of the population, so you shift the environmental diversity. And both of those, short-term and long-term, they drive ecosystem change. So I just wanted to put some pretty pictures up. So I'm based up in Scotland at UKCEH. Apologies, some of the slides we've just changed to UKCEH from CH and the template's all changed. So if things are in the wrong place, it's my fault. So this site at the top here, hopefully some of you may have visited it, but you're all very welcome to come and visit. Sits on a moorland just south of Edinburgh. Those are the Pentland Hills in the background, and it's one of the super sites for the UK for air quality. It has all the UK air quality networks based at it. It's also an ecosystem super site. It's part of the ALTA long-term research infrastructure, and it's also part of the ACTRIS and ICOS infrastructures, so the European research infrastructures for air quality and for climate. So ICOS is the carbon observance system. We also have sites, and there's a couple of sites, super sites as I would say, across the UK. There's also these types of sites which are manipulation sites, where we're looking at the change in systems by putting change onto them. So that this one is Wind Bog, where we release ammonia and we deposit reactive nitrogen and look at the change in the biodiversity, both above ground and below ground. So those manipulation sites where you can have an experiment in the field are also very important for getting this long-term evidence. So strategically, we want to protect human health and ecosystem health. What are the key challenges currently? I would say, if you've read the DEFRA in their strategy and the 25-year environment plan, I'm not going to talk about them, but a lot of the background information comes from them and the discussions around that. Ammonia and reactive nitrogen are key air pollutants currently, coming from our NO2 emissions, from traffic, industry, and ammonia, and its related emissions from agriculture, but also from traffic. Particulate matter is both primary particles coming up from dust and soils, but also secondary particles formed by chemical reactions in the atmosphere. So they're one of the major public health challenges in the UK. PM2.5 is inhalable and is being linked to all sorts of chronic and acute conditions. Ozone is still an issue. It isn't going down very much. It's formed as a secondary pollutant by reaction of the nitrous oxides, nitrogen oxides, and oxygen and photolysis. So I think photochemistry is going to be something quite interesting in a changing climate, which we don't really study very much, to understand how our mix of reactive chemicals is going to change over time. To do this, we need environmental metrology and we need infrastructure and capacity. We need to be able to understand the mosses, the lichens, the trees, all the plants around them. We need to be able to monitor the air. We need to know what activities we're doing in high resolution. So how do we do it? Currently, we have UK air quality networks managed through DEFRA and the Environment Agency, and they primarily relate to the substances which are covered by the European Air Quality Directive and whatever its successor legislation is in the UK. So currently, sulfur dioxide, the nitrogen oxides, ozone. VOC stands for volatile organic chemicals, and that covers thousands of different organic chemicals which we emit with our personal products, by natural activity, and ammonia and PM 2.5. So historically, acidification has been the major challenge with the sulfur dioxide. The NOx and ammonia, they cause acidification and eutrophication of ecosystems. So they damage the vegetation growth with the nitrogen, the plants which aren't so keen on nitrogen, but also promote the growth of the nitrogen-loving grasses and things like that. So in our sensitive ecosystems, nitrogen pollution is one of our key challenges. In parallel, we have the climate changes and land use changes, so the pressures on our ecosystems, the original ecosystems and ones which have been changing over time, trying to decouple all these pressures is quite a challenge. One of the interesting things I'll talk about a little bit later is that in 2018-19, for the first time, we tried to pull together the air quality and the ecosystem networks to look at the metrics together for the first time and understand what that data means. It was quite an interesting exercise. So one of my main jobs, my main hats, is coordinator of one of the UK air quality networks, which is UKEOF, UKEAP, UK Eutrophying and Acidifying Atmospheric Pollutants. We have component networks of the National Ammonia Monitoring Network, acid, gas and aerosols, the wet depositions, the rain chemistry network, and the background nitrogen dioxide network. Our data has been collected since the mid-1980s for some of the pollutants. Others came in the early 2000s. And that data gets used to provide our UK maps for pollutant concentrations and deposition, and then feeds into these metric studies, the critical levels, the above which plants are damaged by pollutants, where is that happening across the UK. And you can see the yellows and the reds just up here of where we've got some of the real challenges on pressures on ecosystems. But that data is used across all spheres of policy, going through the Air Pollution Information Service, which is used by local authorities and consultants, screening tools for planning, going into local environment impact assessments and planning, which is how we need data to be used in general. We need it to be not just a data point for someone to look at and go, oh, that's a concentration. Just going to talk a little bit about some of the data now, though. So the acid, gas and aerosol network is probably the one no one ever hears about. It's 30 sites, now it's down to 27 because there was a few cuts a couple of years ago, which measures the nitric acid, sulfur dioxide, and the composition of particles, so inorganics. And it measures it over time across the country. It's been running for about 16 years now. It had some predecessor sulfur networks. You can see that the higher concentration of the particulate compounds are higher down in the south of England and lower in the north. So you can get spatial long-term data. You also can get temporal long-term data. So this is nitric acid and nitrate in particles over time since 1999. This is the sulfur, and as you can see, the sulfur's gone down radically. Ammonia and ammonium is over here, so the ammonia hasn't changed a lot at all, whereas our ammonium has gone down. So, ammonia. Ammonia is a key challenge pollutant for the UK and globally. The emissions in future climates, this is the best case scenario, is that it stays about the same concentrations as we are currently in. In all other scenarios, it goes up. For every 5 degrees increase in temperature, you double the ambient concentration of ammonia in equilibrium. Why is ammonia important? Because it's a nutrient that's also toxic at different levels, and it changes processes. These are processes in the soils and plants made by a colleague of mine, so I can't explain it to you exactly, but it does a lot within the biological biochemical systems. So there's no single best way of collecting evidence of ammonia because it changes, it's very sticky, it decays very rapidly in the atmosphere, so the concentration at source to background changes very rapidly across the landscape. But we do need to measure it, and we need to have process studies, and we can model and measure it currently, but we can do it better, I think is the... And then we need to work out how to mitigate and recover, what solutions for reducing the emissions and protecting the impact. So this is just a couple of examples of what I mean by it changes rapidly. So this is at a farm, point source, so it's up around 100 micrograms per meter cubed, and the background in this location is less than 1 microgram per meter cubed. So you have the factor of 100 dilution within a couple of hundred meters of the emission source that's sticking to the surfaces, it's diluting and it's forming particles. So you need to be able to understand it and its co-emissions. So it's not just emitted by itself, there are other organic namings emitted which we really don't measure at all in the environment, let alone understand what they do, what their net effect is. The research on this area is starting to pick up. The atmospheric chemistry of ammonia has suddenly become interesting after 30 years of being told it wasn't. Which is, and this is the UK national network summary, so Sim Tang, there should have been a reference there, Sim Tang at CEH is just finishing her PhD on all the network data which she managed for 20 years. The concentrations have not changed since the late 90s. There may be a fractional decrease in some sectors, particularly the poultry sector has gone down a bit. However, agriculture is moving around, so some areas in the UK have gone down in concentrations, others have gone up. So, national ammonia monitoring goes into this cycle, so we do have that. So this new look at data, trying to pull in our ecosystems, under Article 9 of the National Emissions Ceiling Directive, was to pull together the air quality, ozone, air quality and carbon flux data from national networks to deal with freshwater, terrestrial ecosystems, solid and liquid, and vegetation and soil. These data sets, monitoring networks, have never been pulled together before. Which was quite challenging given the spreadsheet and template we had to submit it in. But what it did highlight was we don't have many sites. We had 129 sites which we managed to pull together from all the networks, so the Environmental Change Network, Long-Term Monitoring Network. This is very small, it's on a poster out there. So the Long-Term Monitoring Network from the Nature England, Environmental Change Network, Upland Waters, ICP Forests were the main data sources. The air quality networks were there for the air data, and there's a few greenhouse gas fluxes, and there's a need to coordinate our carbon flux systems. There's more and more sites being set up, but having a look at them in the round and looking at the carbon balance of these ecosystems long term is quite challenging. So we pulled the data together, and we've not made a new database or archive, thankfully. We've pulled the data where we can, and we would be looking to get a shiny system where you can go back, find the original data, but also if we want to have some tools to calculate metrics, that's where we'd like to go with it in the future, because we think it's a key evidence stream. The key monitoring gaps we found from this exercise was that we're not really measuring ozone very much across our ecosystems. We're modelling it for the UK, which is good data and quite robust when it's been tested in the tropospheric ozone assessment. But we don't measure it on ecosystems or agricultural locations in the UK. I think we had less than 5 sites. We also have very few agricultural monitoring locations. We have quite a lot of ecosystems, but we don't have many directly agricultural sites where it's mixed as well. You don't just have agriculture here, an ecosystem there. If you look around the landscape, we are in a mixed landscape. Emerging pollutants, I would say, from my atmospheric chemistry hat on, personal products in air quality is coming up the agenda, and we don't really monitor any of those in the background atmosphere. Plastics, atmospheric deposition and microplastics is happening. There's evidence from Paris and London. Now we're just about, I believe this year, to start doing some background looks to see what's being deposited in our areas where you wouldn't expect the plastic to be, but it's being rained out. And that comes into forever chemicals as well, the PFOS, the perfluorinated, many hundred of year lifetime chemicals. And I think supporting the UK frameworks to have these sentinel sites, the Mauna Loas of the UK, to understand that ecosystem change. And then you will be able to understand what is happening. So what is the impact? What is the metric for studying it? What are the drivers for that, and how can you change it? So you can't change things unless you can actually really identify what's driving the problem in the first place. So I think the summary of the challenges for linking across, I think the social and political scientists, the economists are really important, but also the farmers and the industrialists and the innovations to do low-cost, high-quality monitoring is a holy grail which we're nowhere near. We're getting there for maybe 1 or 2 pollutants, but it's not anywhere near. We need to get industry and innovation working to help us. How do we do interventions while maintaining the industry and farming while keeping people doing things? I think we have a lot of data where, I've talked to the Environment Agency a little bit about this, every impact assessment has some monitoring data which goes and sits in a report. Never sees the light of day again. If we could just change simple things like that, so that when someone does some monitoring for a planning or an impact, or checking of an impact, and that data has to go somewhere and it's publicly available, we would like a country with quite a lot more monitoring data and information. Just goes into a vacuum currently. So I think that would be the simplest legislative change which could actually transform our knowledge, and then we'd have to do a bit of a data risky thing. But that's fine. Okay, thank you very much.